Welcome back to the course Cobotics Theory and Practice. We are running module 2, that is actuators, sensors and safe workspaces. Okay, overview of this lecture would be as follows. So, I will be starting with introduction to sensors, and I will also introduce you to transducers which are part of a sensor. So, optical incremental sensor and encoder, that is to do position and velocity sensing. I will discuss that. I will discuss Hall effect sensors which has multiple applications to various kinds of sensors. I will discuss velocity sensors and acceleration sensors which can be applied for force sensing as well. So, let us begin with sensors. So, it is a device or a module or a machine or a subsystem whose purpose is to detect events or changes in the environment. It includes transducer. What it does, it changes one form of the energy to other form. So, what are the parts of a transducer? Basically, it picks up the signal generated by the sensing element. It converts from one form to the other, that is, it amplifies the picked up signal. It also sometimes they also have linearizing unit which tends to linearize the input to the output, okay, and it transmits the signal. So, basically it integrates to the sensor to communicate the data to a processor. Okay. So, transducer basically the whole of the conversion is from the picking the signal which is generated from the sensing element to communicating it to the processor in digital form nowadays. Okay. So, it includes all of these. So, it basically picks up the value from here, that is from the environment. It may be temperature, it can be pressure, it can be displacement. It converts it, basically amplifies and linearize it electronically, and it has a element that is transmitter which transmits it to the acceptable form, which finally goes to the PC or a microcontroller. Okay. So, both of these, that is transducer and the sensing element, both of these normally are used in conjunction and are commonly referred to as a sensor. So, sensor as a whole nowadays it is transducer and the sensing element combined together is a sensor. Okay. Various types of such devices are, it can be analog device, it can be digital device. Digital device are basically conversion of this analog signal to digitally accepted form, so that it can be accepted by microcontroller or maybe a PC or embedded device some kind of. So, based on that, and it can be analog also when you have a continuous range of values ranging from the whole of the range of the measurement that it can do. Okay. It can communicate using RS-232, I2C, that is 2-wire interface, SPI, Ethernet, etc. for short distance communication, normally for embedded devices. So, these type of communication device it may have to transmit the data, or it can use Profibus, DeviceNet, EtherCAT, Modbus, RS-485, etc. for long distance communication that are mostly common in industry. Okay. So, mind it. So, your sensor has the sensing element and the transducer and the transmitter. Okay. Transducer can convert, it can convert from one form to the other, it amplifies, it linearizes, and finally it transmits it. So, transducer again has got three form conversion as I have discussed. Okay. So, let us start with optical incremental sensor, that is also known as encoder, which is used to measure position and velocity, especially the joint position and the joint velocity in robots. So, construction wise they are very simple. So, it has a slotted window which is there, you see it is a disk with so many windows. There is a light source, is normally LED source, light emitting diode, which is here, and there is a photo sensor which is here, and a squaring circuit which basically converts the analog value which is received by the photosensor to digital form, high and low signal. So basically this setup would simply count the number of windows, okay, as this wheel rotates about this axis. If it rotates, what will happen? It will sometimes see the opaque in between, or sometimes it would see the green colored, which are windows. So these are windows from where the light can pass through and fall on the photosensor. Got it? So effectively, if you have two such LED and two such photosensor, you can have them arranged in a manner like this, two LED and two sensors. So each one of them can give us a square wave output, that is high and low signal. As the wheel rotates, you get a continuous signal which is of high and low. So this is high, this is low, high and low, that will continue. Okay, and there is a slot which is very small window, and that is used as an indexing. So for every complete one rotation, this index will pass and you will get a small high signal only. So with this you can count how many turns it has completed. Okay, so now this senses the relative change in position of each joint. So wherever it starts, let us say this becomes the 0. If it has counted 5 windows and you have, let us say, 360 total windows in this wheel, so 5 window will mean 5 degrees it has turned. So it has simply measured this 5 degree from the starting position to the new position where it is now. So it is basically a relative change in position which it has recorded. So rotational angle, sometimes these slots can be made even on a strip with a small slot which can be there like this, and it can even measure the linear displacement of this strip. Okay, that way it can be used to measure the linear displacement also. You should know how many windows you have in a particular distance. Okay, so position, it can count the position, simply count it and get the position, or it can measure the velocity. So number of windows it has crossed per unit time, that gives you number of high signal it will read per unit time. So counts per unit time will give you the velocity of the encoder wheel. Okay, so and direction can be noted using output A and B. So A and B are phase shifted by some distance. So if it is rotating clockwise or counterclockwise, that can be estimated using the phase A and phase B signals. Okay, so you have two window counters. One is with one LED, other one you will have another one with second LED and second photocell over here, and this both of them can give you phase A and phase B signals. Okay, so direction and the position and velocity, all three of them it can give you. Okay, so it is basically a non-contact type, so it is optically read, so it has long life and they are very rugged. So yes, multiple turns with gears can improve the resolution. So normally these are fitted at the rear part of the motor. You have seen it earlier. In case of DC motor, you have an encoder which is behind, okay, and then you have a gearbox. So your servo motor consisted of encoder and the motor. This was encoder and the motor and the gearbox. So this was the output shaft. Let us say this is a gear with gear ratio 5 times. So what happens? For every 1 turn of this motor, you get 1 by 5 turns of the output shaft. So 1 turn, that means if this wheel has got 360 windows, so 1 turn will give me 360 total of counts that I can read, but output shaft has rotated only by 1 by 5 turns. So what effectively it has done is, for 360 degree by 5 rotations, it has given you 360 counts. So that is the beauty of it. So if it is fitted like that, in that case it can improve the resolution also. So in case of motors, normally it is fitted behind, that directly gives you the count. In front you have a reducing gear which effectively reduces the speed and increases the torque. Okay. So this is how a physical sensor it looks like. So you see, you can physically see this, there is a indexer here and there are multiple windows along this circumference. Okay. So you have a set completely. So these are the connecting terminals. You may have one side LED and other side of it, that is the sensing diode, photo sensor. Okay. So same in case of linear sensor, this is the linear strip with windows you can see. Okay. And one side may have a LED, other side can have the photo sensor. Okay. So this is how it works. Okay. Linear incremental strips can also work in a different way. Here it is the reflecting tape instead of transparent tape. So you have a LED source that gets reflected and it is read over here by the photo detector. So there are many such linear encoder strips. They are so dense that it literally looks gray colored, something like that. Okay. So it looks like gray, you cannot see the windows so clearly. Okay. So linear pickups are very sensitive nowadays, and you have high density encoding which is there on these strips. Okay. So now magnetic position sensor, this again is a contactless sensor. So again the components are sensing circuit with a pickup. Okay. So you have a sensing circuit with a pickup which is shown here, a rotating drum with a series of magnetic poles around the circumference. So these are magnetic poles which are marked here. Okay. So when it rotates, the sensing circuit picks up the counts of how many such magnetic poles has passed by. Okay. So with that also it can detect the angular position of these kind of shafts. So again this can also be arranged in a linear way and you can detect the displacement. Okay. These are few types. So magnetic gear tooth sensor which works on variable reluctance type, the one which is shown here, it looks like that only. Another one, magnetoresistive encoder, which is having a very high resolution, consists of an array of patterned thin film resistors. Okay. So that is magnetoresistive, and the first one is a gear tooth sensor which is a magnetic sensor which is nothing but a variable reluctance. This one is magnetoresistive. The third one is a Hall effect kind of sensor which are magnetic encoders, as in case of AS5600 which is a 12-bit sensor. Okay. So normally these are widely available for embedded projects, you might have used it. So it is nothing but a chip which has a Hall effect sensor, and this needs to be glued on top of the motor. So it has a north pole over here, it has a south pole over here, and when it rotates, this chip can tell you the angular position of this glued magnet. So this magnet is glued on top of the rotating shaft. So that angular position can be precisely told. Okay. So this has a set of Hall effect sensors. So based on the angular position of this north and south pole, depending on the senses that individual Hall effect sensor reads, it detects the angular position of this magnet. Got it? So this again based on the senses, it can be further split into 12-bit of encoding, and finally that 12-bit data can be passed using SDA, serial data, serial clock, and direction. Everything can be sensed from here using standard I2C bus. Okay. So it is meant to be used with embedded sensor. Similar ones are there over here which is shown. This contains a magnetic strip and a pickup which is shown here. Okay. So this also is quite common in joint sensors. Normally in cobots this kind of sensor is very common. Okay. So these are various types which are there. Okay. So based on the magnetic field strength of the moving multipole magnetic drum or the wheel, the response received by the pickup is passed through the signal conditioning circuit. So, there is a signal conditioning circuit. It is not that trivial that you can quickly check that circle and estimate the position. There is signal conditioning which eliminates the noise, amplifies it, filters it, finally segregates the data and digitize that generate the digital signal corresponding to the angular displacement or the position, angular position. Okay. So, this is how it works, that is magnetic position sensor. So, this is very common in cobots. Okay. Cobot joints are normally using this. This is the reason it has to be shielded from electromagnetic waves which are nearby. EMI shielding is to be done. Now, coming to the Hall effect sensor. This is a type of sensor which can be used to detect proximity, position, tilt, velocity, current and many more. Okay. So, this is very widely used in BLDC motors. BLDC motors, you saw you had 3 sensors, phase A, phase B and phase C earlier. So, they give the feel of the sector where your rotor is. Depending on the sector, so you get to know the position of your rotor. Okay. So, it was used for that purpose. It is also used in pneumatic cylinder to detect where it is, either it is fully extended or fully retracted. So, you have 2 Hall effect sensor at each end, whichever is high is the position of the cylinder. Then tachometers, gripper status, open and close can be known. Okay, these are a few, there are many other applications of this. How it works, basically it measures the magnitude of magnetic field. Okay, so this is just a magnet to create the source here. So, magnetic lines of force are shown here. Okay. Its output is directly proportional to the magnetic field strength passing through it. So, this is the Hall effect sensor. The output is proportional to the output Hall voltage is proportional to the magnetic field strength that is passing through this material. Okay. Combined with the threshold detection, that is a comparator, it can act like a switch. So, it can trigger a switch. So, Hall voltage is an analog voltage. So, it varies directly with the magnetic field strength that is here. So, you can make it a trigger so that it is thresholded. So, at particular level it gives you high signal, of below that it will give you low signals. That way it can be used like a proximity sensor. Okay. Applications are proximity sensor, position sensing, speed, tilt and current sensing. So, you know already that these magnetic fields can also be because of current carrying conductor nearby. So, magnetic fields can energize this also. So, if at all there is a conductor with a current that is nearby to this, so this current, higher is the current, higher is the magnetic field and higher is the Hall voltage that you can read. Okay. So, this voltage now will make you estimate the current flowing through any such conductor. Again, if this magnet is used like a tilt sensor, so you know this field B will vary depending on the tilt of this magnet. So, maybe you can calibrate this sensor to be used like a tilt sensor. You have already used it as a position sensor in case of BLDC motor. Speed also can be estimated using those kind of arrangement as it was there in a BLDC motor. Advantages are many. It is very inexpensive. They have high reliability because it is of non-contact type. It does not wear out with time. Okay. So, and also it can detect high frequency operation. That means it can detect very fast. Okay. So, you can just make it on and off, on and off. So, a set of magnets can pass by and you can count each one of them with a high frequency. It can sustain harsh environment also. It is not dependent on dust and moisture also. Only thing, it has to be electronically protected, that is all. Okay. Materials that has such properties are gallium arsenide GaAs, indium arsenide INAS, indium phosphide indium, antimonide, INSB and graphene. So these are some of the materials which are commonly used as a Hall effect sensor. Again, this is the sensing element, okay, it gives you a voltage signal. Now complete sensor is a package which will process this voltage signal. If it is inside a proximity sensor, it will digitize it to 0 and 1. It can have a communicating circuit also which can transfer it using I2C, or it may be Profibus, Profinet. So that communication circuit is in within also. So this is just a sensor, okay, a pure sensor. So it has to include many other components for processing and transmitting. Velocity sensors. So talking about velocity sensors, they are byproduct of mostly position sensors, which are also known as a tachometer, and Hall effect sensor can be used for that reason. Okay, using position sensor, when it is used within certain time bounds, it can give you the velocity. So rate of change of position is actually the velocity. So number of pulses per unit time in case of incremental encoder was the velocity. If at all it is an analog sensor, as in case of a potentiometer, it gives you a voltage which is proportional to the angular position. In that case, you can simply take derivative of the voltage signal and you can obtain the velocity signal. Okay, how that is done? This is not, it is just an operational amplifier which is used as a differentiator here. It gives you a voltage output which is proportional to the rate of change of V in. V in is the input signal over here. Okay. So what is RF? RF is the feedback resistance, and there is a capacitor which goes here. Okay. So that comes here and it is negative. So whatever is the velocity, negative of that is reflected here as voltage output. Okay. So now using a tachometer, it is used as a angular velocity sensor. It works like an alternator. It works simply, you know, if you increase the angular speed of the tachometer, a higher voltage is produced. So voltage produced is proportional to the rate of change of flux linkage, that is changing because of the speed of the shaft. Okay, so higher is the speed of the shaft, higher is the voltage that is seen by the tachometer. That is very common and it is used in quite a lot of industrial applications. It requires an ADC, analog to digital converter, to transfer this data to any microcontroller or a PC. Okay, so a velocity sensor that uses a tachometer normally uses ADC to convert it to appropriate form. This again, tachometer would be a sensor. It needs a transfer of data, so it may have some communication device also. Normally tachometer generates enough of voltage which can be transmitted also in the analog form itself. Okay. So there is yet another very good sensor which can detect accelerations. It is known as accelerometer, which is known as a MEMS micro accelerometer, that is micro electromechanical systems, MEMS sensor. Let us look at that. So working principle is quite straightforward. So this is there in school books, high school physics you have learned. So let's say you have two parallel plates which is here, and there is an intermediate plate which is here. If it is a capacitor, what will happen? If this plate moves, the capacitance which is here and here changes, C1 and C2 changes. So if there is a capacitance change in capacitance sensor, so it can detect the change in capacitance, it can estimate the position of this. So using this principle it is designed. So you have multiple such plates which are here. Okay, so yellow ones which are shown are the fixed fingers, they are like comb. Okay, so they are fixed fingers, and you have the blue one which is shown here, that is on a simply supported beam, which are, these beams are fixed over here, and now this mass which is here is a moving mass. okay, that can oscillate. If you make this object, whole of the assembly go like this, you shake it, so this mass, which is known as proof mass, moves within, okay, and all together is cut using a single silicon wafer, okay. So K is the stiffness of the simply supported beam like structure which behaves like a spring. A is the acceleration of this mass, which is a proof mass. Epsilon 0 is the dielectric constant of the medium which is present here in these spaces, white spaces. C1 and C2 are the capacitance of two sides of the beam, okay, this comb, okay. So this side has C1 and this side has C2 capacitance, okay. Now let us look inside. So you see, this is a proof mass which is floating on a spring of stiffness K, okay. C1 and C2 are the two side capacitance, okay, C1 and C2, okay. So these are the fixed fingers, these are the fixed fingers, and the blue one, this is the proof mass, this is the moving finger, okay. So one side of it, let us say if this whole of the assembly is made to move with an acceleration of x double dot, okay. So at any instant, let us say it has displaced by a distance x from the mean position, okay. So one side of it will have distance between the parallel plates, which is here is d minus x, and other side will go d plus x. D is the mean position distance, that is equal in both the sides, okay. So the capacitance on one side will become epsilon 0 A by d minus x. What is A? A is the area of those plates, d is the initial distance, x is the displacement because of this acceleration. So second side, you see, capacitance becomes epsilon 0 A by d plus x. So this side, you see, capacitance has reduced, this side capacitance has increased, okay. So the total capacitance, because they are in parallel, okay, so it will be C will be equal to C1 plus C2. So total capacitance will be C1 plus C2. So using the force balance equation, what you can estimate is Kx. X is the displacement of the spring that creates the restoring force, that should be equal to the force which is generated due to the acceleration, that is ma. So Kx is equal to ma. So it becomes displacement x is equal to ma by k. Now you see, x is the variation that goes here, that is changing the capacitance. So effectively acceleration becomes the function of capacitance, okay. If there is a circuit which can detect the change in capacitance and create the sensors out of it, so what happens? So whole of this system is a mechanical system, it is creating an electrical change in the circuit. So accordingly it can be detected and signal can be converted and transmitted. So the whole of this becomes a sensor. Effectively what it is sensing? Acceleration, okay. So whole of this is fabricated by photolithography on a single SiO2 wafer, silicon oxide wafer. It is very sensitive with a low noise margin. It is independent of temperature variation because whole of the circuit is embedded within a chip which is known as MEMS chip, accelerometer. Common one is ADXL 345, okay. Applications are many. It looks like this, you see, this is the nano grating that you can see, this is the comb system which is here, and you can see this is a spring like structure which is made here both the sides, and overall this becomes the proof mass which is here. So whole of the mechanical structure is sitting inside, okay, inside the chip, and there are many other conditioning circuit which goes inside, you can see here. So you have a sensor, sense electronics, which converts it to the analog form, analog to digital converter is there, it is filtered and it is power source is there for each of them. Okay, control logic is there, and you have serial input and output system which is here, which finally converts the signal to SDA serial data, that is I2C, and it is transmitted. So clock signal is here, data input and data output is here. Okay, so there are interrupts also which may be generated from here. So this is ADXL 345 chip details. So you see there is sensor, sensing element, that is MEMS, mechanical system. You have sense electronics which detects the change in capacitance, converts it to digital form, filters it, transmits it. So whole of this is a accelerometer sensor. So this you see is independent of temperature variation because it is packed within a vacuum inside the chip. Compatible communication modes are there. It can be I2C, it can be SPI, it can be UART or various other forms in embedded. Okay, it is used for automobile crash detection. Okay, 2G, 3G, 6G sensors are there. For airbag deployment, consumer electronics, for hard disk protection, if hard disk falls, it automatically parks. So that is used also in the laptops. Mobile screen rotation, that is tilt sensor. 3-axis accelerometers are also there. Based on the components of G along all the 3 X, Y, Z direction, you can estimate the tilt also. Okay, so Gx, Gy, Gz is sensed by the 3 directional, 3 orthogonal accelerometers. Okay, those are picked up, converted to tilt, that becomes a tilt sensor. Tilt sensors are used in camera for image stabilization, that is to detect the vibrations also. Okay, and stabilize the image. Industry as a vibration sensor, crack detection, robots, aerospace and defense, it is used for navigation, missile guidance, thrust detection, and many more. So you see, this is one of the very versatile kind of sensor, that is accelerometer. It is a MEMS device and they are very small. It saves a lot of space. Okay, so we have now discussed various types of sensors, especially position sensor, velocity sensor, and accelerometers. In the next lecture, I will discuss force and torque sensor. We will discuss transmission, that is using planetary gearbox and harmonic drives. That's all for this lecture. Thanks a lot.